Good morning! We, the Group 4, will be discussing the Fibonacci sequence in plants. Up until now, Fibonacci sequence had greatly piqued our interest. It is so known, yet still mysterious. Where did Fibonacci come from? Originally, the word Fibonacci was named after an Italian mathematician who discovered the sequence named Leonardo Pisano Bicolio, also known as Fibonacci. History shows that Leonardo discovered the sequence by observing the rate of reproduction of the rabbits, which later on became his basis to form the Fibonacci sequence's value. To begin with, Fibonacci sequence is formed by adding the previous two digits in the sequence. Example is 1 and 2, and the sum of those two numbers will be the next number of the sequence. Repeating the process will give you the Fibonacci sequence itself. Another special thing about this sequence is that its ratio is equivalent to the value of phi. The larger the value of the number in a sequence used as a divisor, the closer it is to the value of phi. Like what you can see in this video, as the value of the number came from the Fibonacci sequence increases, its equivalent value became closer and closer and closer to the value of phi, which is 1.61803. The sequence can be observed very evidently on a plant diagram like this one. You can notice that as the plant grows, the number of its branches and leaves multiplies, and the rate of reproduction of those branches is in accordance to the Fibonacci sequence. Now, let's pretend that you're a plant. I know you're not, but let's pretend. If your petals are overlapping on each other, would it be nice? I guess not. The overlapping of your petals will be inappropriate because the petals on the front will receive more sunlight than those under them. But if we apply the principle of Fibonacci sequence here, we get this value of 222.5 degrees by dividing the phi to the measurement of the circle. 222.5 degrees can also be 137.5. So that's great. Now we can compute the measurement of each petal by using a compass. But if you don't have any, you can use an alternative. You can form your own phi compass by using the corner of your notebook. If you fold it to the edges of the line, you'll have a 45 degrees plus 90 degrees, which is equals to 135 degrees. Pretty close to 137.5 degrees. But if you want it to be more accurate, you can adjust the paper to a couple more degrees. Then detach the phi compass and we're good to go. Now let's start with one leaf. Let's add more leaves that is away from each other at 137.5 degrees to prevent the fight for the sun. And repeat and repeat and repeat this process till you can see how the leaves tend to grow apart with each other. And because the leaves leave extra space behind, there's always a room for the other leaf without forming a whole new layer, which is very practical because as a plant, you would have wanted this. Next, you can also see the pattern of the sequence in a flower with two types of leaves, wider and thinner leaves. With the wider leaves, you only need to start with 3 petals to see the spiral pattern. First draw the first 3 petals, then by using the same measurement, as you proceed with this process, you will see the pattern quickly. But if we started with thinner petals though, the second time you draw the succeeding petals will not result to visible patterns. Plus, it will take around 8 petals for you to see the spirals. So that's it. So all that you as a plant needs to do in achieving the amazing Fibonacci sequence spirals is to add new bits at 137.5 degree angles, which is, remember, is derived from the number of the Fibonacci sequence. Now, always remember that Fibonacci sequence is not only made for plants. There's also things in which this sequence can be applied to the future, not only of insects, but more importantly, of our own bodies and one's curiosities. Still, the sequence has endless application. So even if you qualm yourself because you're unable to pass the NatSci 1 exam, still, the effects of Fibonacci not just only satisfies our curiosity, but it also enlightens our minds to the sequence that once became a part of our mystery. And that's all. Thank you for watching, and with the Group 4 always remind you to stay curious.